Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in the last lecture we have studied the numerical which was based on Faraday's first law, but now we are going to do the numerical which is based on Faraday's second law. So let us see the question and let us see how to find out the answer. So as mentioned on your screen, there is a question which is based on Faraday's second law, which says that in a certain electrolysis, 0.561 gram of Zn, that is zinc, is being deposited in a cell containing ZnSO4 solution. So calculate the mass of copper deposited in another cell containing CuSO4 solution, and both the cells are connected in series. As well as they have also mentioned a few extra data that is very much essential for us, that is molecular weight of zinc, which is given as 65.4 gram per mole, and molecular weight of copper, which is given as 63.5 gram per mole. So this is a numerical which is based on Faraday's second law, and since they have mentioned that the cell is connected in series, it is quite obvious that it is based on Faraday's second law, because Faraday's second law has only a theory where both the cells or both the half cells are connected in series and the same amount of current is applied throughout the whole cell, and the weight deposited is dependent on the equivalent weight of the particular substance that is getting deposited on the particular electrode. So based on this, let us differentiate or let us extract the data from the given question and let us see how can we find out the answer. So the given data says they have provided weight, that is mass of zinc, as 0.561 gram, and for that we have to calculate the mass or the amount of copper which is getting deposited in the cell of where CuSO4 is present. So this is what we have to calculate. And the next thing that they have provided to us is molar mass of zinc, which is given as 65.4 gram per mole, while that of molar mass of copper is given as 63.5 gram per mole. So these are the data that are being given in the question. So now what we are going to do is we have to calculate what would be the mass of the copper in the that would have been deposited in the second cell. So before doing this, let us calculate the number of moles of the zinc as well as the number of moles of the electron that is being involved in the whole process. So for that, the first formula that we are going to do is we are going to calculate what is the number of moles of a particular substance. So first of all, the first thing that we are going to do is we have to find out the number of moles of the substance. In this case, we have to calculate the number of moles of zinc, because the weight of zinc is already provided to us. So therefore, since we know the number of moles formula, that is N is equals to weight divided by molecular weight, while in this case the weight, that is actually the mass of zinc which is provided to us, is 0.561, while the molecular weight is given to be 65.4 gram per mole. So the answer would be, so after evaluating this, we will get an answer as so this is the value that we will get by the number of moles that we have calculated. And now this number of moles will be very much influential in finding out the number of moles of copper. How? But for that we have to calculate what is the mole ratio. And what is the mole ratio? Let me tell you. The second thing that we have to do in this process is to calculate the mole ratio. Mole ratio is nothing but the amount of the substance that is been getting deposited, or the number of moles of the substance that is been deposited divided by the total number of electrons that take place in that half cell. So let me tell you with an example. In this case, the zinc is being obtained when it is dipped in a solution of ZnSO4. So in this case, if I would say that zinc which is present in an aqueous form, that is Zn2 plus, will accept 2 electrons to form zinc, and then only this will get deposited as zinc. So therefore zinc 2 plus, which is in aqueous form, will accept 2 moles of electron, then only it will get deposited as solid zinc. So to understand mole ratio, let me give you the formula of the mole ratio as, and since we are talking about zinc, so therefore the mole ratio of zinc will be equals to the number of moles, or the 1 mole of zinc divided by the total number of moles of electrons involved in that process. So in this process, to obtain 1 mole of zinc, we have to arrange, or we have to this solution has to accept 2 moles of electrons. So therefore the mole ratio will be 1 mole of zinc divided by the 2 moles of electron required in this process. So similarly we could calculate the mole ratio for copper also. How? Copper that is present in Cu2 plus, that is which is present in aqueous form, it will accept 2 electrons, then only it will get deposited as copper. So therefore Cu2 plus, which is in aqueous form, it will accept 2 electrons to form a solid copper that will deposit on a particular electrode. So therefore how can we calculate the mole ratio? It will be very much simple. So therefore the mole ratio will be, for copper in this case, will be 1 mole of copper divided by the total number of electrons that are being involved in this process to convert an aqueous form of copper to a solid form of copper is 2 moles of electron. So this is how we have calculated the mole ratio of copper as well as mole ratio of zinc. So by making, or by understanding these 2 data that we have recently calculated, we can also find out what would be the number of moles of copper and what would be the number of moles of zinc that are being involved in the overall reaction. So let us see. So for that we have a formula. Since we know for Faraday's second law of electrolysis, the number of moles of zinc, or the number of moles of, I would say as A, divided by the number of moles of B, it will be equivalent to, or it will be equal to, mole ratio of A divided by the mole ratio of B. So let us consider the mole ratio of A as the mole ratio of zinc, and the mole ratio of B as mole ratio of copper. So therefore we could write the following in this way as the number of moles of zinc divided by the number of moles of copper, which is equivalent to mole ratio of zinc to the mole ratio of copper. So in this case, I could write the number of moles of zinc that has been we have been calculated as, that is 8.577 into 10 raised to minus 3 divided by the number of moles of copper. I would write it in this way, that is N of Cu, which is equals to the number of moles of zinc which is been calculated. It was nothing but 1 mole of zinc divided by 2 electrons. Similarly, we could write it for the mole ratio of copper also, like 1 mole of copper divided by 2 electron. And by this process, this 2 electron will get cancelled out, and because of the help of this, we could calculate what would be the number of copper. So let us do. So therefore, the 8.577 into 10 raised to minus 3 divided by the number of moles of copper is equals to 1 mole of zinc divided by 1 mole of copper. Therefore, the NCU, that is the number of moles of copper, it will be 8.577 into 10 raised to minus 3 into 1 mole of copper divided by 1 mole of zinc. So this will cancel out each other because it is the number of moles. So therefore, the N mole of Cu will be So the number of moles of copper was being calculated. So now, because of the help of that, we could calculate what would be the amount or what could be the mass of the copper that has been deposited in the half cell reaction. So therefore, what I could write it as, since I know, I could write the number of moles of copper as the mass of copper, that is weight of copper, divided by molecular weight of copper. So the number of moles of copper has been calculated as 8.577 into 10 raised to minus 3, and therefore the mass of copper that has to be calculated, or the amount of copper that has to be calculated, divided by the molecular weight of copper. So in this case, the molecular weight of copper that they have provided to us is 63.5 gram per mole. So therefore, the mass of copper will be 8.577 into 10 raised to minus 3 into 63.5. So if we calculate this thing, we could get the answer as 0.544 gram. So this is how we could calculate the amount of a particular substance involved in a series of the cells that are connected with each other, and that will follow Faraday's second law. So this was very much simple to calculate. So thank you friends for watching this video. I hope you have got an idea that how to calculate this kind of data and how to calculate this kind of requirement. So please share this video with your friends, and yes, don't forget to subscribe Ekeeda channel. Thank you so much.